Hello, this is Dr. Ryan Johnson with the course Introduction to Statistics at Grace College. This is the video for Section 5.1's worksheet. So you should have already read Section 5.1 in the reading. It was about nearsightedness and whether or not the kids, whether or not there had been a nightlight in the kids' bedroom and whether or not they developed the need for glasses or contacts. So I think it's a pretty interesting study. So hopefully that was shown a light on the idea of causation. And so now we're going to look at the worksheet for 5.1. So in this section 5.1, we're talking about how association and confounding relate to each other. So we are looking at the Oklahoma City Thunder, and there was an article back in 2009 from Sports Illustrated looking at how the Oklahoma City Thunder did a lot better. They won more games when they did not sell out than when they did, and how that's on the surface seems strange. So we'll dive in a little deeper and see if something can make sense, if we can make sense out of it. So first, for exercise 5.1, identify the observational units and variables in this study. Also classify each variable as categorical, binary, or quantitative. So there should be two variables you notice here. So make sure you label them which kind. That's just an important thing that we need to do every time we have a new data set. So number 2, when did the Thunder have a higher winning percentage, in front of a sellout crowd or a smaller crowd? Support your answer. When I am doing these sorts of things, I find it useful to highlight some of the important numbers. And so this team had a win-loss record that was actually worse for home games with a sellout crowd. So sellout crowd, they were 3 wins and 15 losses. And without a sellout crowd, they were 12 wins and 11 losses. Okay. So, so when did have a higher winner percentage? So you should actually calculate the two different fractions there and compare them. So turn them into decimals. Turn the two fractions into decimals. That makes it easier to compare the size and tell me about them. Okay. So for definition 5.1.1, two variables are associated or related if the value of one variable gives you information about the value of the other. So for instance, if I'm seeing if there's a difference in numbers based on the variable, there's a difference of win-loss based on the variable sellout or not, then I'm seeing some association, which is I just answered number 3 for you right there. Okay. So definition 5.2, the explanatory variable and the response variable. My highlighting's being weird, but oh well. Okay. Explanatory variable is the variable we think is explaining the change. Response variable is the variable we think is being impacted by the change. So whenever you've got a situation where one variable is determined before the other one, you always want to determine, time works one way. So you always want the thing that is kind of determined first to be your explanatory variable, the thing that's determined second to be your response variable. Otherwise, you're kind of using your wisdom and common sense in regards to which one is which. And sometimes you can be wrong. Okay, so which we consider the explanatory variable in this study, which is the response. So you should be able to determine those by when they're determined. Is the sellout crowd happening first, or is the win or loss of the game happening first? Okay, and so there's two possible explanations. Once we've kind of figured out it can't go the other way. Either the sellout crowd caused the Thunder to play worse, or the sellout crowd did not cause a worse performance. Some other issue, variable, explains why they had a worse winning percentage with sellout crowds. In other words, a third variable is at play, or fourth or fifth, that could explain both both differences. Okay, there could also be random chance. That's another explanation. But what things we've been learning about inference, and eventually we'll learn enough about inference to be able to say this difference is too big for randomness to really be a good explanation. Okay, so number 5. Consider the second explanation. Suggest a plausible alternative variable that could explain why the team would be less likely to win in front of a sellout crowd than in front of a smaller crowd. So useful sentences here, and I want to highlight that note. Make sure it's clear. Not just that your explanation would affect the team's likelihood of winning, but also that be less likely to win in front of a sellout crowd compared to a smaller crowd. Okay? So use your common sense and wisdom to come up with an explanation here. And if you're totally lost, you can try reading ahead because there'll be hints. But if you're able to do it without reading ahead, then gold star to you. All right, so a confounding variable is a variable that's related to both the explanatory and response variable, and it can explain both of them. So identify the confounding variable based on your suggested explanation from number 5. Explain how it is confounding. What is the link between the third variable and the response variable, and what is the link between the third variable and the explanatory variable? Okay. Now, a good hint for 5 and 6 is another variable that was recorded here. Another variable recorded for these data was whether the opponent had a winning record the previous season. Of the Thunder's 41 home games, so of the 41 home games, 22 were against a team that won more than half their games. Let's refer to those 22 as strong opponents. Of these 22 games, of the 22, 13 were sellouts. Of the 19 against a weak opponent, only 5 of those games were sellouts. Okay? So was the Thunder more likely to have a sellout crowd against a strong opponent or a weak opponent? Calculate the relevant conditional proportions. So calculate the two fractions and compare them. So calculate them as decimals and compare them. And that's how you answer number 7. Now, when the Thunder played a strong opponent, they won only 4 of the 22 games. When they played a weak opponent, they won 11 of the 19 games. So was the Thunder less likely to win against a strong opponent than a weak one? So again, calculate the relevant conditional proportions, that is the two fractions, calculate them as decimals, compare them to support your answer. So both 7 and 8 should have a calculation part and a full sentence part. Okay? Number 9, explain how your answers to 7 and 8 establish that strength of opponent is confounding variable. So explain why the fact that strong versus weak opponents is associated with both of my variables can prevent drawing cause and effect between the two original variables. Okay, so explain means full sentences. I don't like how that does that. I'm going to erase that. Okay. Now, summarize your conclusions about whether these data provide evidence that a sellout crowd caused the Thunder to play worse. Write as if to a friend who has never studied statistics. Be sure to address the fact that the Thunder had a much smaller winning percentage in front of a sellout crowd. So try to avoid too many of the words that we've used, and try to use just like, but your friend, assume your friend hasn't taken a stats class, but they understand math. And so use the math to explain to them why the strength of the opponent could be the element of causation instead of the just like the sellout crowd causing the win-loss. Okay, make sure to use complete sentences. So confounding explains why you cannot draw a cause and effect conclusion from association alone. Okay, the groups defined by explanatory variable could differ in more ways than just explanatory variable and confounding present. So for instance, if you've got home games, sellout crowd, not a sellout crowd, win, loss, these are observational units. There's a response, there's the explanation. But the sellout crowd could be caused by the strong opponent, and the not sellout crowd could have a cause of the weaker opponent, and we can't break that apart then. So we can't, even if causation was happening, because there's confounding variables, we can't draw that apart. We can't tell what's causing what. That makes sense? All right, this ends our section 5.1 video.